Hello everyone, this is Shubhajyoti Moitra from MATLAB and Tech Chat. Today we will discuss on the fitting of data over curve, various curve. Suppose I have experimental data, okay, I have captured experimental data. That data can be captured in anywhere. Suppose you are performing experiments of any particular project and you are capturing data in your laboratory, okay. Now that data you have stored in your desktop or laptop in a system. Now question is how that data can be fit over a particular model or curve. That I will demonstrate today in MATLAB, okay. So here you can see, just a minute, I am going to the view section. I am clear all output, okay. So here you can see this is the MATLAB code, okay. Actually this is called as a .mlx file, or also known as live editor. That is the main feature that is available under your new version of MATLAB. The basic difference between live editor and editor, if anyone are interested to know that, I will upload another video on this, okay. So this is the live editor and here is the main code, okay, MATLAB code I have written here. The problem is I have taken an example that suppose the temperature is varying with respect to time, okay. This temperature is nothing but the room temperature. The room temperature is varying with respect to time. So here is the time vector. The time is starting from 0 second and the final value of time I have taken here the 21 second. So generally it is started from 0 second and end at the point 21 second, okay. So from 0 to 21 I am recording, sorry, I am totally wrong, sorry, I have a mistake here. Actually the start time is 0 and end time is 20, okay. So between 0 and 20 we are recording 21 number of data points having in the time vector, okay. So here is the time vector. We are using the linspace function to generate the time vector. It will start from 0 second and end at the 20 second, end up to it will move up to the 20 second, and between 0 and 20 it will record 21 number of data points of the time, okay. Similarly temperature should have the similar length of this time vector, okay. Here the temperature will start from 20 degrees centigrade. We have taken 20 degrees centigrade and it is varying in this fashion, 20, 21, 22, 23, 24 and so on, increasing, decreasing, increasing, decreasing. In this fashion the temperature is varying. Suppose the temperature is varying in this fashion. Now the question is how we can fit this data point on a particular curve or model. Now here, before going to plot the curve and plot the data points over the curve, we have to know which curve we are plotting here. Generally we have to set a function here. As you can see, these are the user defined function, okay. In MATLAB you can perform user defined function in this way. You can create that function using the function call, okay. So here is the model. The model is nothing but it is a polynomial model or polynomial curve, okay. And this polynomial will have any type of degree. It may be a first order polynomial, it may be second order polynomial, it may be third order polynomial and so on. So based on the nature of the data points or pattern of variation of data, we have to select the order of this polynomial, okay. So here this is the model I have created. So polyfit is a function we have to use for creating or constructing the model, polynomial model, and in order to get the result you have to use the polyval function. Okay, you have to use the polyval function. Now here is the plotting function. You are plotting the data temperature with respect to time, and in the similar plot you are plotting the output also. Output means that output that you are getting from this model. How you are calculating this output here you are calling this function result model, because model is already created using the function fit model. You are already getting the output model here from the function fit model, and after getting the result of the model you are calculating the output data points from the result function. Okay, so you are plotting this result function also over this original data point in order to check that variation of your data points and which curve will be best fitted. Now here arbitrarily I have taken the order of the polynomial is 9th. That means it is a 9th degree polynomial. Okay, now I am running this MATLAB code. After that I can understand that how this data point is varying. Yeah, so it is successfully converged. The MATLAB program is already completed. Here you can see the variation of the data points. This circle represents the data points and the continuous line representing the your model, polynomial model. Okay, so in this way you can fit the model over the data. So this is a very simple process. Now in order to check the goodness of fit, that is very much important in this aspect, you have to use the RMSE value, that is root mean square. Now how you can calculate that? SQRT, that is square root mean of the, you have to use the absolute value also, the absolute function, in order to get the only the value. Temperature is your original data, and out is your model output. Okay, so we are getting the RMSE value is equal to 2.7822. so this is the output. Okay, now suppose your model is suppose this pattern of your data, variation of data is it is other type, or it is not as per my chosen data. Okay, so in that case your model order may be varied, or RMSE value also may change in that case. So this is the process, basic process for fitting the particular polynomial model over your variation data, in order to understand how your data points are varying. So I think you have understood. Thank you.